Hello everyone, my name is Renyu Rui. I'm going to introduce our paper named PIRenderer, Controllable Portrait Image Generation via Semantic Neural Rendering. In this paper, we deal with the portrait image editing task, which requires generating images by modifying the expressions and rotations of a given reference image. Some previous work tried to solve this problem with the stereogram-based method. For example, steering describes a method to control stereogram via a 3D MM. Mapping functions are trained to transform stereogram length variables according to the provided target motions described by 3D MM coefficients. However, since the method takes the stereogram length variables as inputs, they rely on image projection techniques such as image-to-stereogram for real-world image editing. Some other works employ warping-based methods to estimate the deformations between the sources and targets. However, many existing methods use indirect motion descriptors such as edges, keypoints to describe the target motions, which hence the model's ability for intuitive image editing. The proposed PIRenderer uses a subset of 3D MM parameters as a motion descriptor. In this model, a 3D face shape is parameterized with alpha and beta describing facial identity and expression respectively. Let's assume a fixed camera model. The desired motion can be clearly expressed with beta, rotation R, and translation T. Please note that we do not use alpha here since the person identities are irrelevant with the target motions. The architecture of a proposed model is shown in this slide. Our model can be divided into several components that fulfill specific tasks. The mapping network is used to produce length vectors from the motion descriptors. Instructed by the vectors, the warping network estimates the deformations between sources and desired targets. It generates coarse results by warping sources with the estimated deformations. The editing network generates the final images by modifying the artifacts of the warped coarse results. Several loss functions are designed for training the model. A reconstruction loss is used to calculate the perceptual error between the warped images and the target images. For the editing network, both style and content losses are calculated for the final prediction. Our PIRenderer controls the poses and expressions of the source images with the user-provided coefficients. It can be used as a photo editor which can modify the semantics of the source images. Meanwhile, our model achieves competitive results in the talking head motion imitation task. We show that the proposed model generates more realistic results along with accurate movements while still preserving the source identities. Additionally, we show the potential of our model as an efficient neural renderer by further extending it to tackle the audio-driven facial reenactment task. Directly mapping audio signals to images is challenging, since motion-irrelevant factors such as identity illumination will interfere with the model. Therefore, employing semantically meaningful parameters like 3D MM as the intermediate results can significantly ease the task. An additional mapping function is trained to produce various sequential 3D MM coefficients from audios. Our model generates various video from only a single portrait image and a driving audio stream. Please check our paper and project for more details.